Greetings. Today we're going to talk about a math concept called perfect numbers. The Greeks were always looking for beauty and perfection in their mathematics, so they were after the definition of what they called a perfect number. Now let's look at some numbers and look at their factors, or also called their divisors. For example, if you have the number 7, the factors are 1 times 7. Well, the Greeks mathematicians liked to play around with numbers and do different things with them to see what would happen if they could find any patterns in numbers. So they started adding up the factors of a number. For example, for 7, you'd add up 1 and 7. Now what they would do is they would throw out the number itself, add up the factors, and for the number 7, when they added up the other factors, you'd find just 1. Now that happens with all prime numbers. Prime numbers, if you add up the factors other than itself, you're just going to get 1. So we looked at other numbers like 8. So 8, the factors are 1 times 8 and 2 times 4. Remember, we're going to throw out the number 8, add up the factors. 4 plus 2 is 6, plus 1 is 7. Now they call this a deficient number, meaning the factors added up to less than the number itself. So 7 is less than 8. Okay, they're searching for other numbers. They looked at the number 10. The factors are 1 and 2 and 5. They added those up. We got 8. Again, 10 is a deficient number. Let's take a look at some other numbers. Now there's another concept called superabundant numbers, meaning the Greeks looked at, for example, the number 24, found all its factors other than itself. 24 has lots of factor pairs, 1 times 24, 2 times 12, 3 times 8, 4 times 6. If you add up all those factors, not including the number itself, you get 36. 36 is larger than 24. They call that superabundant. They were after perfection. They were after trying to see if there are any numbers that when you added up all the factors that actually equal to the number that you started with. That was important to them, this symmetry, these patterns that they were looking for. Excuse me. We're testing the audio capability of a Prezi today, so this is the first time I've tried it. Moving on, number 30, look into factors. Number 30 is also superabundant. When you take all the factors of 30, it adds up to 42. 42 is larger than 30. So the Greeks tested lots and lots of numbers, and they were finding very few that they would be considered to be perfect numbers. Let's find out if we can find any. So for perfect numbers, let's first make a formal definition. Well, we've been saying that the addition of the divisors of a perfect number should be equal to the number itself. All right, so again, the prime numbers didn't work. The first number that they stumbled upon was the number 6. 6 factors into 1 times 6 and 2 times 3. So if we throw out the number itself, add up the divisors, we actually find out this was 6. This is the first perfect number that the Greeks stumbled upon. And they thought that the 6 had magical powers. They even said that the earth must have been created in 6 days, or so I've read. Now, they said what other perfect numbers are out there. Now, if you have a lot of time and patience, you can start finding the next perfect number. I'm not going to make you do that today, but what they found out was you don't stumble upon the next perfect number until you hit the number 28. 1 plus 2 plus 4 plus 7 plus 14 is 28. Now it gets harder and harder to find these perfect numbers. The next one's at 496. If you have even more in time and patience, the next one is at 8,128. And I imagine the Greeks probably stopped there. They would have trouble until the computer was invented. Someone would have to have quite the time and patience to find the very next one. Turns out the very next one is at 33,550,336. So again, I imagine we had to wait for computers to come along to find the next perfect number. So if you have some time and patience and you're a little bored, see if you can find the next one after 33,550,336. I imagine you might want to write a computer program to do that. Anyway, this was a nice introduction to perfect numbers. We'll talk to you later.